I am back with the video of the video series on class 9 science motion, and in this video we are going to practice numericals. Yes, and that is something which most of the children are extremely afraid of. Yes, so we are going to practice many numericals, and after watching this video you will be confident enough to attempt all the unsolved questions in your textbook. Trust me. So watch the entire video and ace the numericals in physics. Let's get started.
It says an athlete completes one round of a circular track of diameter 200 meters in 40 seconds. Okay, so let us suppose that you have an athlete here and he covers one round of this circular track. So if you assume this as a circle, so he covers one round of this track in 40 seconds. Right? Now diameter is given as 200 meters. Time to cover one round is 40 seconds. That means in 40 seconds he covers one round. And what is this one round? One round means how much distance? That is nothing but the circumference of the circle, and circumference of the circle is given by 2 pi r. So this will be 2 pi into r is nothing but diameter divided by 2. Right? So this 2 and 2 will get cancelled. So it is 200 pi meters. So that means this much is the distance which he covers in 40 seconds. Now we have to calculate that what will be the distance covered and the displacement at the end of 2 minutes 20 seconds. That means in 40 seconds he covers 200 pi meters distance. So how much distance will it cover in 2 minutes 20 seconds? So first let us convert 2 minutes 20 seconds into seconds. So 1 minute is 60 seconds. So 2 minutes will be 2 into 60 seconds plus 20 seconds. So how much time is this? It is 140 seconds. Right? So let us try to calculate the distance first. Now in 40 seconds, the distance covered is 200 pi. So what will be the distance covered in 140 seconds? So in 140 seconds, it will be 200 pi divided by 40 into 140. So this comes out to be 700 pi. Now pi is 22 by 7. So this 7 will get cancelled. So it will be 2200 meters. So this would be the total distance covered at the end of 2 minutes 20 seconds. Now we have to calculate the displacement. Now what is displacement? Displacement is nothing but the distance between the initial point and the final point. Now in 140 seconds, now 40 seconds meant one round. Now 40 seconds means one round. So 140 seconds would mean how many rounds? So for one round he needs 40 seconds. For 2 rounds he would need 80 seconds. For 3 rounds he would need 120 seconds. Correct? That means in 120 seconds he will cover 3 rounds. Right? And in 40 seconds, so that means 1, 2, 3 rounds covered in 120 seconds. So how many seconds are remaining? 20 more seconds. So in 20 seconds, he will cover another half round. Right? Because in 40 seconds, he is covering one round. So in 20 seconds, he will cover one round. So that means this total 140 seconds corresponds to 3.5 rounds. Right? So that means in 3.5 rounds means if you start at this point, so he will cover 1 round, 2 round, 3 round and then half round. So his final point will be here. Please understand this carefully. Suppose he starts from this point. So he will cover 1 round, 2 round, 3 round and 3.5. So that means this will be his final point and this was his initial point. Right? Now the distance between the initial and the final point is the displacement. Right? So what is my displacement here? Distance between initial and final point is nothing but the diameter of the circle. And what is my diameter? The diameter is 200 meters. You understood how we calculated it? Distance was simple, right? We first saw that in 40 seconds he covered this much distance. Therefore, in 140 seconds he will cover this much distance. When talking about displacement, we have to determine the initial and the final point. Now, in order to determine the initial and final point, we should know how many rounds will it cover in 140 seconds. So that is what we did. First, we calculated that in 140 seconds he will cover 3.5 rounds. Now, using that 3.5 rounds, we were able to find the initial point and the final point, and with that we could find the displacement. Right? Okay. Now let us look at the next problem. It says that Usha swims in a 90-meter long pool. She covers 180 meters in 1 minute by swimming from one end to the other and back along the same path. Let us suppose this is the swimming pool. A and B represents the two ends of the swimming pool. Now the problem says that the length of the swimming pool is 90 meters. So that means the distance between A and B is 90 meters, right? Now she covers 180 meters in 1 minute by swimming from one end to another and back along the same straight path. That means she starts from this end, goes here, again starts from this end and comes back here. So that means what is the total distance that she is covering? 180 meters. And how much time she takes to do that? She takes 1 minute. So we have to calculate the average speed and the average velocity. So let us first calculate average speed. So how do we calculate average speed? Average speed is given by the total distance traveled divided by the total time taken. So what is the total distance traveled from A to B and then again from B to A? So she travels a total of 180 meters. And what is the total time taken to do so? It says she covers 180 meters in 1 minute. That means the total time taken is 1 minute. 1 minute is 60 seconds. So this comes out to be 3 meters per second. So this is the average speed. Now what would be the average velocity? So when we talk of velocity, it is given by total displacement divided by the total time taken. Now what will be the total displacement in this case? The distance between the initial and the final point. So initial point is point A, and what is the final point? Final point is again A, because she goes from A to B and comes back from B to A. So since the initial and the final point are the same, so the average velocity would be 0 meter per second. Right? Okay. Now let us look at the third problem. It says Joseph jogs from one end A to the other end B of a straight 300-meter road in 2 minutes 50 seconds and then turns around and jogs 100 meters back to point C in another 1 minute. So in this case, what happens? So Joseph starts from one end A. So let us say this is end A of a straight road which is 300 meters long and reaches the other end B. So this is the other end B. And the length of this entire road is 300 meters. So he covers this 300 meters in 2 minutes 50 seconds. Right? Then he turns around. So from point B, he turns around and jogs 100 meters to point C. So he jogs some 100 meters and reaches this point C. And this 100 meters, to travel this 100 meters, he takes how much time? To travel this much, he takes 1 minute. And to travel this 300 meters, he takes 2 minutes 50 seconds. Right? So what are Joseph's average speeds and velocities in jogging from A to B and from A to C? So let us first try to solve the first part, that is from A to B. So from A to B, we have to calculate the average speed and average velocity. So first calculate average speed. Average speed would be nothing but the total distance traveled divided by the total time taken. So from A to B, what is the total distance traveled? It is 300 meters. And what is the total time taken? Time taken to cover this 300 meter is 2 minutes 50 seconds. So 2 minutes 50 seconds is 2 into 60 plus 50. So we converted it into seconds. So this comes out to be 30 by 17, which is equal to 1.765 meter per second. So this is the average speed. Now what would be the average velocity in this case? Now in this case, the Joseph moves from A to B in the shortest possible path. I mean, in this case, the distance and displacement both are equal to 300 meters. So average velocity will also come out to be 1.765 meter per second. Because average velocity would be total displacement by time taken, and the total displacement will also be 300 meters. Now let us look at the second part, that is from A to C. From A to C. In this case, what would be the average speed? Average speed would be the total distance divided by the total time taken. So in this case, total distance would be A to B plus B to C. That means this will be AB plus BC divided by time taken. So time taken will also add up. That means this time taken plus this 1 minute. So this will be equal to, so 2 minutes 50 seconds was 2 into 60 plus 50. That was 170 seconds plus this extra 1 minute, which is equal to 60 seconds. So this will be 300 plus 100 divided by 230. So this comes out to be 1.739 meter per second. So this will be the average speed while traveling from A to C. Now let us try to calculate the average velocity. So what would be the average velocity in this case? It would be the total displacement divided by the total time taken. So what will be the total displacement? Here initial point is A, final point is C. So the shortest distance between A and C is this one. And how much is this distance? This will be 300 minus 100, that is 200 meters. So the displacement will be 200 meters divided by time taken. Time taken will be the total time taken. That means this 230 seconds, that is the time taken to reach from A to B and B to C. So that is 230. So this comes out to be 0.87 meter per second. So this would be the average velocity. So I hope that with the help of these examples, it is becoming more clear to you that how do we calculate average speed and average velocities. It says that the odometer of a car reached 2000 kilometers at the start of a trip and 2400 kilometers at the end of the trip. That means, let us suppose you are going out from home. When you are about to start, the reading on your car, you know the car odometer, right? Where the driver sits, there you would see that there is a small string which actually points out the number of kilometers which are already run. So now let us suppose that when you start your trip, that time it points to 2000 kilometers, and when you come back from your trip, it points to 2400 kilometers. And your entire trip took you 8 hours. So you have to calculate the average speed in kilometers per hour and meter per second. Now what is the total distance covered in the trip? It will be 2400 minus 2000 kilometers, that is 400 kilometers, right? Because it was already at 2000. So after that, whatever kilometers have increased, that is the distance covered. So that means it is 400 kilometers. And how much is the time taken to cover 400 kilometers? It is 8 hours. Therefore, the average speed will be equal to the total distance covered divided by the time taken, that is equal to 400 divided by 8 kilometers per hour, that is equal to 50 kilometers per hour. Now they also want the answer in meter per second, so let us convert it into meter per second. 1 kilometer is equal to 1000 meters, and 1 hour is 60 minutes and 1 minute is 60 seconds. So this is how we converted it into meter per second. So it comes out to be 13.9 meter per second. Right? Okay. So let us look at the fifth problem. It says, Abdul, while driving to school, computes the average speed for his trip to be 20 kilometers per hour. Okay. On his return trip along the same route, there is less traffic and the average speed is 40 kilometers per hour. Okay. So what is the average speed for Abdul's trip? That means let us suppose this is his home and this is his school. Now, while going from home to school, his average speed is 20 km per hour. While coming back from school to home, his average speed is 40 km per hour. So, for the entire trip, what is the average speed? So, I told you before also, many people make a mistake that they add up these two average speeds. But that is not correct. So, as I told you, whenever we want to calculate average speed, which approach will we follow? Total distance travelled by total time taken. Right? So, while going to his school, what is the distance that he is covering? Let us suppose that the distance between his house and the school is D. So, the total distance he is covering while going is D. And let us suppose that the time taken while going is T1. Now, according to the question, average speed will be equal to average, and right now I am talking only about while going. So, while going, average speed will be equal to the total distance divided by total time, and this value is given as 20 km per hour. Right? So, from this, we can say that T1 is equal to D by 20. So, this is my equation 1. Now, let us look at the return journey. What happens while returning? Now, while returning, again he travels the same distance D. But while returning, the time taken is different, because it says that while returning the traffic was less, therefore his speed was more. So, if your speed is more, you will take lesser time, right? So, the time here is T2. So, while in the return journey, the average speed will be equal to D by T2, and it is given as 40 kilometers per hour. So, from this we can say that T2 is equal to D by 40, and this is equation 2. So, therefore, we can say that the net average speed for the entire journey will be equal to, for the entire journey, total distance travelled is D plus D, that is 2D, divided by the total time taken is T1 plus T2, right? So, in this we can write 2D divided by, instead of T1 I can write it as D by 20. Similarly, instead of T2 I can write it as D by 40. So, this comes out to be 2D divided by D into 3 by 40. So, DD will get cancelled. So, this comes out to be 80 by 3, that is equal to 26.67 meter per second. So, this would be the average speed for Abdul's trip. So, this is the average speed for the entire trip, which includes his going to the school and his coming back from the school as well. So, please have a special look at this type of problem, because most of the students make mistakes in these kind of problems. Whenever they have average speed while going, average speed while coming back, if they want to calculate the net average speed, they will just add the two average speeds. But that is absolutely incorrect, right? So, please pay attention in these kind of problems. Now, let us look at the last problem of this section. So, it is based on graph. It says that the figure shows the distance time graph of three objects A, B and C. Study the graph and answer the following questions. So, let us look at the first question. It says, which of the three is traveling the fastest? Now, what determines which is traveling faster and which is traveling slower? Which quantity determines that? Right, it is speed which determines that. Now, when you have a distance time graph, how can you get an idea about speed from the distance time graph? Absolutely, the slope of the graph tells us the speed, right? So, that means who will have maximum speed? Fastest will be the one who will have maximum speed. maximum speed will be the one who will have maximum slope. So in this case, if you look at it, which will have maximum slope, because slope is given by tan theta. So speed is given by the slope and slope is given by tan theta. Where is theta? Theta for B is this. Theta for A will be this angle. Theta for C will be this angle. So if you compare the thetas, theta for B is maximum, right? Therefore, slope is maximum for B, and therefore B is the one who will be traveling the fastest, right? So just by looking at the graph, we could say that which of the three will be traveling the fastest. Now the next problem. Are all three ever at the same point on the road? Do you think that there is any such point where the three of them, A, B, C, are at the same point on the road? Look at the graph carefully. Do you see any such point where all the three meet each other? See, if you look at this point, B and A, B and C meet each other. That means at this point of time, both B and C are at the same point on the road. Similarly, at this point, both B and A are on the same point on the road. But at this point of time, where is C? C is at some other position, that is at some 8 kilometers, right? Similarly, at this point, A and C are at the same point. So that means there is no such point where all of them are at the same point on the road. Because in that case, there would have been a point of intersection for all the three lines. So the answer is no. Third one, how far has C traveled when B passes A? So which is the point where B passes A? This is B and this is A. So B passes A at this point. Right? So this is the point where B passes A. Now when B passes A, at that point of time, at what time B passes A? At this time. So at this time, how far has C traveled? So if you look at the plot of C, he had traveled, this is C. I'm sorry. So this is where C is. This point denotes where C is. So corresponding to this point is this much distance. So C has traveled this much distance. Now, how much distance has C traveled? We have to calculate that, right? So, what is the value for this point? Now, let us see how much does one box represent. First, we have to calculate that. So, here if you see for 0 to 4, for a distance of 4 kilometers is represented by how many boxes? 1, 2, 3, 4, 5, 6, 7. So, that means 7 boxes represent 4 kilometers, right? That means one box will represent 4 by 7 kilometers, correct? So now if you see, this is where C will be at this point of time, and C started moving from this point. So that means this is the distance which C has traveled when B passes A. So how many boxes are there between these 2 points? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 boxes, correct? So that means the distance traveled by C, distance covered by C will be equal to 9 into 4 by 7 kilometers. That is equal to 36 by 7 kilometers, which is equal to somewhere around 5.7 kilometers. So this is the distance covered by C. Now, how far has B traveled by the time it passes C? So, when B passes C at this point. So, how much has B traveled at this point? So, the distance which B has traveled at this point corresponds to this portion, right? So, how many boxes B started moving from 0? Right, so in a similar fashion as part C, you can solve part D as well, right? The number of boxes corresponding to this part where B is crossing C. So see, this is another approach how we solve problems related to graphs. right? We have just found out the measurement of one box. One box represents how many kilometers. So similarly, you calculate the fourth part on your own on similar lines as part C. Let us look at problem 1. A bus decreases its speed from 80 kilometers per hour to 60 kilometers per hour in 5 seconds. So that means initially, another convention which we will use while solving problems is that initial velocity will be represented by u. Initial velocity will be represented by u. Final velocity will be represented by v. Time will be represented by t, and acceleration will be represented by a. These are some of the representations which we will be using consistently everywhere. So here it says that the bus decreases its speed from 80 kilometers per hour to 60 kilometers per hour. That means initial velocity was 80 kilometers per hour. Final velocity is 60 kilometers per hour. In how much time does it decrease this velocity? Time is 5 seconds. Right? Now we have to find out the acceleration of the bus. What is acceleration? Acceleration is nothing but change in velocity by time, that is dv by dt. So what is the change in velocity here? Final velocity minus initial velocity divided by time. Correct? Now this is given in seconds and these are given in kilometers per hour. So let us convert these also in meter per second. So for that, what will we do? We will multiply it by 1000 divided by 60 into 60. This meter per second. Similarly, this can also be written as 60 into 1000 because 1 kilometer is 1000 meters divided by 1 hour is 60 minutes and 1 minute is 60 seconds. So 60 into 60. So this becomes equal to 60 minus 80 into 1000 divided by 60 into 60. This divided by t, time is 5. So this is minus 20 divided by 5 into 1000 divided by 60 into 60. So from this we get it as minus 1.12 meter per second square. So what does this negative sign indicate? This negative sign tells us that the velocity decreases with time. So that is why sometimes, so that means this is what? This is retardation, right? Because the velocity is decreasing with time. Since in this case acceleration comes out with a negative sign, so sometimes it is also known as negative acceleration, right? So the acceleration comes out to be minus 1.12 meter per second square. Let us look at the next problem. It says a train starting from a railway station and moving with uniform acceleration attains a speed of 40 kilometers per hour in 10 minutes. So the train is starting from the railway station. That means initially the train is at rest, right? After some time it attains a speed of 40 kilometers per hour. So this is my final velocity. How much time it takes to reach this speed? It takes a time of 10 minutes. Right? We have to calculate the acceleration. So now we can convert this time into hour. So this becomes 10 by 60 hour, that is 1 by 6 hour. So acceleration is change in velocity, that is v minus u by t. U is 0, so this is v by t. So this becomes 40 divided by 1 by 6, which is equal to 240 kilometer per hour square. Now if you want to convert it into meter per second square, you can do so. 240 into 1000, because 1 kilometer is equal to 1000 meters, divided by hour square. 1 hour is 60 into 60 seconds. So this square. So this comes out to be 0.0185 meter per second square. So this would be the acceleration of the train. Let us look at problem 3. It says, starting from a stationary position, Rahul paddles his bicycle to attain a velocity of 6 meter per second in 30 seconds. That means initially he was at rest, so u is equal to 0. After some time he attains a velocity of 6 meter per second. How much time he takes to do so? 30 seconds. Okay, fine. So this is the first part. Then he applies brakes such that the velocity of the bicycle comes down to 4 meter per second in the next 5 seconds. So in case 2, what does he do? In case 2, his final velocity becomes 4 meter per second. And what was his initial velocity? His initial velocity was 6 meter per second, because in the second case, he was already moving with a velocity of 6 meter per second, right? So this becomes his initial velocity, and then he applies brake, so his final velocity becomes 4 meter per second. And how much time he takes to do so? He takes 5 seconds. So we have to find out the acceleration in both these cases. So we will use the same formula. So here acceleration will be change in velocity by time taken, that is 6 minus 0 divided by 30. This comes out to be 1 by 5, which is equal to 0.2 meter per second square. So here acceleration is positive because the speed is increasing from 0 to 6. In this case, acceleration is v minus u divided by t, which is equal to 4 minus 6 divided by 5, which is equal to minus 0.4 meter per second square. So here the acceleration is negative because the speed is decreasing from 6 meter per second to 4 meter per second. Right? Okay, let us look at the last problem of this section again. The speed time graph for a car is shown in the figure. Find how far does the car travel in the first 4 seconds. So we have to calculate the total distance traveled by the car in the first 4 seconds. So which is the graph which is given here? It is given here as speed time graph. Now we have studied that from a velocity, if you have a velocity time graph, how do you get displacement? Area under the curve gives you displacement, right? Similarly, if you have a speed time graph, area under the curve will give you distance, right? Because the relationship of speed and distance is the same as the relationship between velocity and displacement, right? So here you have to calculate the total distance traveled in the first 4 seconds. First 4 seconds would mean till here. So that means the area under the curve up to first 4 seconds. So this would be the area under the curve for the first 4 seconds. These are my first 4 seconds. So area under this curve. So this is my shaded area which will display. So area of this shaded region would be the distance covered. So distance covered will be equal to area of, let me call this point as A and this point as B. Area of triangle OAB, even though it is not exactly a triangle, but it is somewhat similar to triangle. Because even if you draw a triangle, you are covering the most of the area. This is negligible, so we can consider it as the triangle. So area of a triangle is half into base into height. So what is base? Base is nothing but OB. Height is nothing but AB. So this will be equal to half into 4 into, what is AB? AB is nothing but 6. So this is equal to 12 meters. So 12 meters is the distance covered in the first 4 seconds. So we have shaded the area on the graph that represents the distance traveled by the car during this period. So we have already shaded that region. In the second part it says which part of the graph represents uniform motion of the car. So which part represents uniform motion? Uniform motion would mean that the car is moving with uniform speed. Uniform motion would mean the car is moving with a constant speed. The speed doesn't change with time. Now if you look at this graph, in the initial portion the speed increases with time, again it increases. But from this part onwards, if you see, the speed is constant with time. So uniform motion is represented by the portion AC. So I hope with the help of some of these problems which we have solved now, it would have become clear to you that how do we approach problems based on whatever theory we studied so far. So with this, I'll conclude my discussion on acceleration and also the graphical representation of motion.
I hope you found this video useful. In the next video, we are going to learn about acceleration. Stay tuned.